Good afternoon again. We resume our session. We'll have two speakers, remarkable speakers, I would say, with very interesting presentations. The first speaker would be George Saliba. I don't think he needs any presentation for one of the leading presenters of the history of sciences. Today he will talk to us about the mystery of the decline of Islamic sciences. George, you have the floor.
Okay, thank you, Mustafa. I also thank the Academy for inviting me to participate in this. You can all hear me correctly this way? Very good. And before I go on, let us not kid each other. There was a decline, okay? And the reason for it is that we have evidence of the decline. There are people who still deny it up till now. They say, no, we didn't go into decline, everything is okay. The proof that I have is that we do not have anymore in present day, nor did we have 200 years ago, the creative genius of people like Razi, like Ibn Sina, like Bayruni, like Abdul Latif al-Baghdadi, like Urdi, like Tusi, like Ibn Nafis, Ibn Shatir, Khafri. None of these exist. So there was an actual decline, and this is the issue that I would like to address today with you, and hopefully redirect the question and say, when did it happen? It's not that there was a decline or not was a decline. There was one, and we would like to know when did it happen, and hopefully try to figure out why. And together, I think today, I would look at the evidence that is usually given. Most people say, well, decline, and if you read, by the way, any literature on either written by Orientalists or even, unfortunately, by Muslims and Arabs themselves, and there is still this poor attack on Ghazali. They say because Ghazali wrote this famous Tahafut al-Falasifa, that killed science altogether in the Islamic civilization, and that's it. From there on, we can sleep happily with it. Then there are people who say there was an external cause of a decline, and then they immediately point to the Mongolian invasion, which devastated Baghdad in the year 1258. And the sources are filled with the literature on how horrendous it was, how horrible, how barbaric, and all of that. And of course they say, how could you expect to have anything after this barbarity has invaded the whole Muslim world altogether? And this is, again, just a clear vision of the roots of the Mongol invasion, which in fact did take place. However, if we were to believe that both of those explanations, either one of them, did indeed cause a decline in Islamic civilization, then we have real problems. Problems in the sense that we have evidence that we would not know how to explain it theoretically. If Ghazali, for example, was responsible for the death of Islamic science, then I don't know what to do with the works of people like Jazari, like Abdul Latif al-Baghdadi, like Ibn al-Baytar, like Urdi, Tusi, Ibn al-Nafis, Qutb al-Din al-Shirazi, Kamal al-Din al-Farisi, Nizam al-Din al-Nisaburi, Ibn al-Shatir, Jamshid al-Kashi, Qadi Zad al-Rumi, Ulugh Beg, Ala al-Din al-Qushji, Khafri, and so on. This is only to list a few. All of them lived and worked and died after Ghazali. So if Ghazali killed those sciences, what were these guys doing? How do I explain their work? How do I explain it in terms of Islamic science? And if the Mongolian invasion did indeed cause this famous destruction, then what do I do with the most famous observatory ever built in the Islamic civilization in the city of Maragha, built 1 year after the destruction of Baghdad? Baghdad was destroyed 1258. The Maragha Observatory was set up between 1259 and 1260. How could that happen if that civilization was totally devastated? Moreover, what would I do if this were the case, with the works of Nasiruddin al-Tusi, Urdi, Shirazi, Nishaburi, all of them worked at Maragha and produced the best astronomy Islamic civilization had ever known. This, together with others, like Maghribi, Najmuddin al-Katibi, and all of those works, should not exist if the Mongolian invasion has already devastated the Islamic civilization. Who taught those people? Who gave them the jobs? How did they produce? What conditions they produce? And so on. And then what do I do with the famous work of Ibn al-Fawati, who tells us in his Mu'jam al-Alqab that he had a library brought up to Maragha of about 400,000 books, and in his Mu'jam al-Alqab kept almost a diary of all the people that he met with who came and visited that library, which means that there was a very vibrant intellectual activity taking place in Maragha. If this was the destruction, then I would like another distraction tomorrow to give us a fantastic, vibrant academic environment that somebody like Ibn al-Fawati would actually speak about. So all of this is simply to say that these two explanations do not explain the facts that we have. And as scientists, I hope that we all agree that all theoretization, if it is not made and based on the facts on the ground, is useless. So why do we keep thinking in fictitious terms and not account for the facts that we actually have? So all of this evidence begs us to explain it and begs us to reorient our thinking about Islamic science and about its decline and when did it decline. What seems to be clear, and from the names just mentioned that I say, there seems to have been a continuous scientific tradition all the way till the 16th century, despite Ghazali and despite the Mongolian invasion. So these are the facts on the ground, and I'd like to account for them. Something must have happened in the 16th century, and what seems to have slowed down the scientific progress, which we're still seeing up till this very day. It has been slipping after the 16th century progressively till this very day. Therefore, the crucial point is the 16th century. Not Ghazali, not the devastation of Baghdad. And the 16th century, we know something about it. This is the century of Copernicus, of Vesalius, and right after in the 17th century of Kepler, Galileo, Tycho Brahe, and the whole scientific revolution comes after them. The 16th century is crucial because we know a little bit that it was technically, and here I mean mathematically, technically, in mathematical astronomical terms, deeply influenced by Islamic science. I have time only to give you a few examples of how deeply influenced was the 16th century Europe, the Renaissance science, how deeply it was affected by Islamic science. This is the model for the movement of the moon inherited from the ancient Greek tradition. And if you notice on the right, on your left-hand side, when the moon is supposed to be quarter moon, the Greek tradition predicts that it will be twice as big as when the moon is actually full moon. Somebody like Ibn Shatir in Damascus, who died in 1375, a full 100 years plus after the devastation of Baghdad, a full 200 or 300 years after the death of Baghdad, he said, Lam yura kadhalika, meaning as a good scientist, he said, I have never seen the moon at quarter moon be twice as big. Therefore, I need to account for it with a new mathematics. This is the mathematics that's proposed by Ibn Shatir, as you see it there on your right. Who comes after them? About 150 years later, none other than the 16th century Copernicus, who adopts exactly the same mathematics as that of Ibn Shatir. If that was an age of decline, I would like an age of decline tomorrow. These are brilliant mathematicians who are actually solving very fundamental problems and who are actually participating in what now can be called a universal science. What Ibn Shatir produces in Damascus gets integrated into the works of the Polish mathematician Copernicus, and you see it in the Latin text exactly as predicted by Ibn Shatir. What do I do then? Also, this is the 16th century where Copernicus also inherits a very fundamental theorem from Nasiruddin al-Tusi, which the essence of the theorem is to say that we can produce linear motion as a result of two circular motions. I hope this works. Yes, watch that red point. It goes up and down linear line as a result of two circular motions. I don't have the time to train you into becoming good astronomers and mathematicians so that you will understand what it means to the Aristotelian world when you destroy the relationship between linear motion and circular motion. This very essential theorem was also adopted by Copernicus, and as you notice, just look at the Arabic text, which is proving that theorem. Look at the Latin text, which proves it over there. Where you have Aleph in Arabic, you have A in Latin. Where you have Jim in Arabic, you have G in Latin. Where you have Dal in Arabic, you have D in Latin. Where you have Ba in Arabic, you have B in Latin. Every single point. If I ask you to draw a triangle and say put ABC, you put them anywhere you want. Why do you have to put them in exactly the same positions that Nasiruddin Tusi had put them 200 years earlier? There was one professor from Harvard who noticed that Zain in Arabic is rendered by an F in the Latin. He says, you see, he's not copying all the way. But look at the relationship between Zain and Fa in Arabic. They're easily confusable, and it is a problem of somebody misreading the Zain into an F. So what we have is a Copernicus, with the help of somebody, trying to understand the diagram of Nasiruddin Tusi, and making a mistake in reading. This is the 16th century that we know, and this is the material we know, and this is how intimate the mathematics and the astronomy of the Islamic civilization was embedded in it. Joseph Needham noticed the same thing. About 50 years ago or so, he noticed that the 16th century had the Chinese civilization, the Islamic civilization, and the European civilization were almost all on equal footing. And he raised the question, how come that modern science could rise in Europe only, and not in Islam, nor in China? His only mistake is that he went back and started trying to find out what was wrong in the Chinese civilization, could not produce it. And since Needham's time, we have had every second Muslim who thinks twice, or every second Arab who thinks 3 times, trying to find out what went wrong in Islam. Instead of redirecting the question, since both Islam and China is not Islamic, by the way, they also did not produce modern science, the question should be, what went right in Europe? Right between inverted commas now. And I would like to actually begin to think about it, and to share with you what I think the advantages we get if we reprogram our minds away from the prejudices of the last 200 years. What seems to have happened in the 16th century has nothing to do with science to start with, but it has a lot to do with the distribution of wealth and is a major shift in the world organization. Let me give you an example. The world before the 16th century, just the 16th century, was just about what we see in this map. More or less the ancient world as we know it, with the big chunks of Europe, Asia, and Africa as we know them, and more or less it was a discovered world. The main trade routes before the 16th century, all of them, like every single one of them, were really crisscrossing all across the Islamic world. You all know, the more trade you have, the more business you have, the more culture you have, the more progress you have, and so on. The economy is vitalized by the trade. And what we have here are major trade routes crossing the Islamic world from east to west and producing wealth. And sure enough, despite the wars, despite the internecine fights, the dynasties and all of that, there was still enough wealth to be produced to produce those brilliant scientists what we know. After the conquest of Constantinople by 1453, and with the Ottoman armies advancing all the way into Central Europe, there was a serious problem for any European who is sitting there trying to figure where their trade is going to come from and their resources are coming from. So there begins to have dreams in Europe of alternate routes to the east to re-participate in that trade. And those dreams are materialized, for example, excuse the slamming of these things because I'm working from not my computer. This is somebody else's computer I'm working from. One such dream is the dream of somebody by the name of Martin Behaim, who died about 1507. His own vision of the world, look at this world that he has produced on the globe. The one on the right that you see shows at the very edge is the continent of Africa and then a little bit of Spain over it. The continent, the one on the left, shows the eastern shores. No Atlantic, of course, no Pacific, no continent of America, nothing. This is exactly how Behaim saw it. And this is the world that Copernicus actually inherited. The real world, in fact, in comparison, look at the vastness of the Pacific Ocean. It is almost twice and a half as big as the Atlantic Ocean. And that is the real world that they had to, but neither Copernicus nor Behaim, Columbus nor Behaim ever dreamt that the world is really that vast. Nobody would have ventured to go east if they knew that there is still another Pacific Ocean to cross before you get to India. This is the globe, again, as I said, of Mr. Behaim's, and this is the globe, the map that was also handed by Columbus. Notice in both cases, you have the word for Chipano right in here, which is really for Japan. So they both think that a little hop from Spain in here, you can hit and you are already in Japan. So it is just a little sea called the Atlantic. We can cross it and you will be over the other side. The yellow lines around the map of Columbus tells us why, in fact, when he reached Hispaniola in Latin America, he called them Indians. He thought he reached India. He had no idea that he still has a continent and another Pacific Ocean to cross. So as a result, the Indian Americans, the poor Native Americans, are still called Red Indians up till today because of a mistake of somebody who didn't know what was the big size of the world and adventured foolishly, and sometimes big mistakes yield something. It's just like when you hit the jackpot. I go back to the trade routes. Look at those trade routes before 1492, before the discovery of the New World, and look what happened after 1492. You see where the trade is going? All across the Atlantic, into the Americas, and once the Pacific was discovered, from the Americas into the Pacific, and very, very little was going through the Islamic world with the Portuguese discoveries around Africa. Now you can see they are circumambulating Africa and they are trading there, and the Islamic world was left with no trade. How could they make money? How can you possibly support scientists, support academies, do all these things if there is no money? And if there is no trade, there is no money. This period was immediately followed by something called the Age of Discovery, which very quickly translated itself into, of course, the Age of Colonization. The codes of the colors, I hope, you see, with all those bright lights, you can see the colors in here. The coloring of the upper North America, all tagged on to Britain, and then Australia, and then you can see the distribution of the world was really redistributed after these major shifts in the trade routes. The results of this Age of Discovery. Mr. Chairman, you will remind me if I have 5 minutes left, okay? Once you get to the 5 minutes, I think I still have a lot more than 5 minutes. The Age of Discovery produced then the following consequences. It brought gold and silver back to Europe literally in tons. Some of the ships that were bringing gold and silver are still sunk around the Florida coast, and up till now there are people claiming whose gold is it? Is it the Spanish gold, or it is the Floridans, or is it anybody's who finds it? So there are literally ships of gold and silver that come to Europe. There also came a very important economic addition, which is African and Native American slaves. That is slave labor, that is capital, ladies and gentlemen. It doesn't come, if you have to buy it, it will cost you a lot of money. But now it comes free. You just pick up those people, take them in as slaves, and they will work. Then you end up with surplus capital. Who was it earlier who was saying the basis of foundations? It was, I think, our friend Farouk Al-Baz. He says, if you don't have the excess of the production, you're not going to have a civilization. Now you have excess capital in Europe. And this excess capital also began to realize for the first time that it was generated by dependence on science. And hence, science can be redeployed now to raise further capital. And we see it, for example, with the emphasis on navigational examples, navigational tools, that most of them were also picked up from the Islamic civilization. One brilliant example, for example, is this astrolabe that you see on the lower right-hand side. It is all in Arabic, but it is copied by the hand of the architect that you see his name, Antonio de Sangallo, over there, who built St. Peter's in Rome. This is the architect from Florence who lived about the middle of the 16th century. He was so interested in this astrolabe that was made in Baghdad about the year 850. Just to indicate to you the heightened interest of using scientific instruments for further explorations as the Europeans realized that they can actually begin now to invest in the science itself if they have the right tools. There were prizes, for example, set in the end of the 16th century for the person who could actually produce a tool that will tell us our longitude on sea, which is a very difficult problem to tell. Yet, this is where the capital was invested to create these competitions and to create those prizes. Some of the investments, the very first investment, we know about it in the early part of the 17th century, was to re-survey all the medical plans of what was then called the New Spain, which is Mexico, in fact. That, for the purpose, of course, of extracting medical plants for purposes of commercial use. Science then began to produce capital. This is how they began to see it. And it no longer seeks the Aristotelian certainty. Remember, science before, it was science for science's sake. We wanted to know the truth. That's what Aristotle told us. Now we're saying we want science to make money. Science is a commercial activity, commercial producing activity, and hence we need to think of it in different terms, and I have consequences for you. Instead of patronizing science, as we used to do in the Islamic civilization, as patrons would give a gift to a person who writes a book on science, now we will produce science as an investment. So you put money expecting to get back a lot more when it comes back to you. And then science itself began to be organized as a business. In what sense do I mean that? The first patent was produced in Venice in the year 1477. The Venetians did not realize how important it is at the time. It was. But very quickly, when science began to have the commercial tone to it, patenting began to be extremely important. So this is part of the organization of the investment. Academies were not organized just to give each other prizes and shields at the end of the day. Academies were there to create a pool of good-thinking people, and out of 100 people that I can patronize and leave them to think, if one of them will produce a commercial activity for me, that will fund the whole academy. So those academies were really institutes of advanced research. The first example of it is the Accademia dei Lincei, the oldest academy in Europe, to whom none other than Galileo joined. And hence you have first the brains being attached to these academies, and of course, once you get a group of people together in one place, and you have to fund them so that they don't have to worry about their breakfast the next morning, they will produce for you. Royal societies began to be also proliferate. It's not accidental that the four major royal societies all happened between 1600 and 1650. It is just at that time when the full realization that this enterprise of science needs to be seen and organized as a business activity, and hence as an advanced research activity, but well-funded, mind you. The East India Company is a brilliant example of that. The Crown gave the East India Company a monopoly for 30 years to trade with the East, and the East, I bet you, was defined as east of the Thames River. Anything that is east, the East India Company monopolized it. You have the right for that monopoly. This is translation of this fantastic activity now into business and making tons of money, further enriching European societies in general. And once there was, of course, the British East India Company, then there was, of course, the Dutch East India Company, the French East India Company, the Spanish East. All of them knew that this monopoly is very useful. And hence we can create that monopoly, ladies and gentlemen, is just a different word for patenting. Patents are nothing, or patents, no matter what you call them, are nothing but minuscule monopolies. And that monopolistic system has a moral value, as we will question a little bit. I will give you the example of Galileo himself, the father of modern science, who worked mostly, a good number of time. I think he worked at the Venetian Arsenal and the commercial navy much more than he worked at the university, because he knew there was a business to get. And when he got his telescope, and he pointed it at Jupiter, and he saw the moons of Jupiter, he didn't go home and write a treatise and say, there collapses the Aristotelian world because I have an evidence. Actually, he has the best evidence. He didn't do that. What did he do? He wrote to the King of France. He says, I found new stars in the skies. I'm willing to name them after you if you pay me. The French king said, no, 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 I don't want to play with these things. He wrote to the Pope. He didn't give up. He said, I'll call them the papal stars. Also, the Pope said, it's not my kingdom. He sold them to the Medicis, and he got the full life appointment as the court mathematician for the rest of it. So he was doing it for business. He was not doing it to discover the truth of Aristotelian values or not, or the Aristotelian universe for that matter. He produces something that's called the geometric and military compass, which is a mechanism which we have the likes of it, a whole history of it in the Arab world, and we have also the history of it passing through Michelangelo and the rest. But this is not the point. What he did, he wanted to monopolize it. So what he do? He sued his own student for infringing on the patent of that military compass. That's the father of modern science. That's what he was doing, translating science into commercial activity. A colleague from Harvard wrote a book. He calls them Galileo's instruments of credit. He means every instrument, he used it to raise further credit for it. But that, with the father of modern science, what it did, it crucified, crystallized modern science as a problem of competing over monopolies. From there, patenting began to be part and parcel of how modern science operates, and I have a feeling that it even orients the research of good scientists all over the modern world. Why not in Islam or China? Why didn't they develop a similar patenting system and hence develop science as a commercial activity? I say there are real reasons. For one thing, in Islam in particular, I don't know about the Chinese tradition on that one, monopoly is kufr. We know that. Man ihtakara kafara. This is the most common repetition of it. So hence, the idea of monopolizing something will not be condoned. And then we know from the hadith of the Prophet himself, it says, who owns knowledge and he deprives his fellow people from it, he will come at the day of judgment bridled with a bridle of fire. من علم علما وكتمه جاء به يوم القيامة ملجما بلجام من نار. So imagine the kind of horrible punishment for people who will try to monopolize knowledge and keep it to themselves. These are ethical issues, meaning how far now are we willing to allow this patenting system to take over our moral values. Look at the history of patenting. As I said, originally in the monopolies of the East India companies, it went for 30 years. Western societies themselves realized that this is really immoral. So they began to reduce the date and the years of patenting. The latest in the United States now is you can only have a patent for a few years, 4 to 5 years. If it were morally free, why not give a patent for life? So they also know that there is a moral compromise being done when you allow your patenting to deprive the society from knowledge that is absolutely essential to them. That is where religion interferes with science. Not when Ghazali writes Tahafut al-Falasifa. Is when religion does not allow you to compromise your moral values and does not allow you to monopolize a knowledge that is useful to the society. That is when the price comes in and religion says, we have to be very careful in that. So what do we do with modern Islamic societies? What are the implications of this lesson for us? Now that we know what allowed Europe to actually surge on, can we do the same in Islamic societies? The Prime Minister, Mahathir, actually has set up in Malaysia a fantastically similar system where with my own ears, I heard the Minister of Malaysia for Science, Technology and Innovation says, I don't want scientists to produce science in the lab, I want scientists to produce science for the market. This is a brilliant interpretation of this. Can we do that? Is it possible for Islamic societies to actually resolve this ethical issue? Can we relax in the same way the Europeans relaxed that ethical issue? I know that the International Juridical Union has been struggling since the 1970s with the issue of intellectual property. And up till now, what I have read so far is that they are arguing whether the intellectual property is a property for you or it is something that can be shared or you have to share. But they haven't come into the next level, which says that property can be sold and bought and capitalized on in the same way patents are done. They have to resolve that, and they have to resolve the hadith of the Prophet that whoever actually withholds knowledge from society, that person جاء يوم القيامة ملجما بلجام من نار. This is the duty of the jurists. They have to think about it for our modern Islamic world. They have to adjudicate intellectual property. We have to set rules for it. We have to understand what does it mean, when can it be patented, and if patented, for whose benefit, and for how long, and how we tamper it so that we don't kill incentives at the same time. So patenting creates incentives, but at the same time, it has this moral downside. How about what the jurists always resorted to when they were in a bottleneck? They always resorted to something called al-maslaha al-amma. If I can find a jurist nowadays who can convince fellow jurists that we are in such a desperate situation, that the maslaha al-amma taqtadi, that we have to relax that requirement on withholding knowledge by tampering it by some other reward. For example, to make sure that whoever will be given a patent, that he or she will donate 60% of it back to zakat or whatever to benefit the society. Such techniques, such hiyal in law, are not new to Islamic society. All we need is brilliant new jurists to actually think about it. I hope that now I can conclude, and I think this is the very end of it. I hope that I have persuaded you to stop thinking what went wrong in Islam, or the awful Mongolian invasion. They're both awful. There is no doubt it was a devastation, but it didn't kill the activity. I also wanted you to begin to think that this phenomena that we call the discovery of the New World, and which necessitated colonialism, was not particular to Islam or to China. It is a universal phenomenon, and now it divides the world into the ones who have taken the benefit of lowering that moral bar and accepting patenting and monopolies, and hence instituting a business as a result of it, and the rest of the world who is still struggling on what to do with this monopoly. Thank you very much for your patience. Now I think if I turn it off, the next speaker has his he can have his way with it.
Thank you very much, George. I think you would agree with me this was the most thrilling presentation. And I think we should take on board the main lesson of this presentation, that science needs money, that and commitment of the rulers. And I think he made the proof that when government supported science, Islam developed science, and when this stopped, we started the decline. This has been said by the Academy of Sciences for many years. Now, I think it will take us some time before the next speaker fixes the computer. I invite Falcon to come. And, very good.
We will see.
We'll see. Anyway,
It could happen very fast or not.
Charles Falcon will talk to us about an amazing scientist whom soon we'll celebrate 1,000 years, anniversary I think it is. That is Ibn al-Haytham. I hope this will be fast and we will enjoy the talk.
I'll find very shortly. So I have no idea. How long I'm supposed to speak. So I get to speak as long as I want, because so we're going to see how this goes. So what I want to do today is talk about a Arab scientist, and I'm going to tell you how we came across him. And I've got to hold many things simultaneously. Turns out you can't carry a green laser pointer to Europe without having it confiscated. So all I have is a really pathetic red one, which is probably next to useless. So maybe I won't even try that. So I'm going to talk about Ibn al-Haytham and his influence on essentially the entire spectrum of European civilization. Now, Ibn al-Haytham is known in many languages by slightly different names, some of which you can see there. And he's so loved, at least in the Islamic world, by some people that almost simultaneously in Baghdad, Saddam Hussein named the Ibn al-Haytham Missile Research and Development Center after him. And not to be outdone by that, in Tehran, the center where isotope separation is conducted today is named after Ibn al-Haytham. A lot to cover today. So I'm going to go through a general introduction to what this is all about. I am not a Muslim. I'm a scientist, not a historian of science. I work in an area called molecular beam epitaxy. So for me to be talking about Ibn al-Haytham, I need to tell you why. Where does this come from? And we've made some real discoveries about him that we will come to today. We'll talk about theories of vision, because it's through his theories of vision that I came across him and have made these discoveries I'm going to talk about. And then I'm going to tell you various things about his influence on science, literature, art, religion. And for this is always an interesting part of my talks in the Islamic world. For you to understand his influence on European religion, I'm going to have to teach you Roman Catholic theology. So we have a lot to accomplish today in this afternoon. And then, so what? So after this is all done, I'll have talked to you for a little while this afternoon. What good is that? I mean, you'll take it away, you'll be happy with it, but I want to talk about how I'm trying to use this knowledge for good in the world. And we'll talk about that a little bit. So we'll talk about Roman Catholic theology. So as an introduction, most scholars would agree optical instruments first appeared late in the Renaissance when Galileo invented the telescope. People that are experts in history of science know that Galileo actually didn't invent the telescope, but he stole the idea. He was a very interesting person. George Saliba told us about some of the interesting things he did, including he was very good at taking credit for things he didn't necessarily do. But the telescope came 1600. Mirrors clearly only reflect images. If you want to focus an image, it requires a lens. Turns out that's wrong also, and I'll show you that that's wrong. And Renaissance masters produced their work by sheer genius alone. I'm going to show you that that's wrong. So the discoveries that I'm going to talk about actually get to the foundations of a liberal education. We came across this, and I wish we could turn off the lights. I mean, This just really is terrible because we wash out all sorts of things, and it's going to get even more colorful as we go along. I mean, if we just kill these entirely, that entire bank of lights, I'll do my best to keep everybody in the audience awake, even if the lights are out. So David Hockney is somebody I've collaborated with in some discoveries that I'm going to just touch on today. Arguably the most critically acclaimed British artist of his generation, perhaps the greatest of modern portraitists. So what David Hockney...
I admit, for instance, I am interested in pictures. I keep saying this. I'm interested in how you make pictures.
So I'll repeat. He said he's interested in pictures. He's interested in how you make pictures. I wish we could have sound hooked up. David Hockney, through his entire career, has been interested in analyzing how images are made. This brings us directly, although we didn't realize it at the time, to Ibn al-Haytham. And so as a result of our discoveries, ironically, I have a thesis named after me in the area of art history, even though I'm a scientist. And we've analyzed paintings and we've made various discoveries that optics were used 200 years before Galileo by such famous European painters as Hans Holbein, Jan van Eyck, and others. When we realized Jan van Eyck, one of the most iconic Western painters of any time, that he had used optics to project images 200 years before Galileo, that naturally raised the question in my mind, well, where did he come up with this idea? How did he figure out they used optics? Did it just come to him one morning? Or was he informed by something else that came earlier? That led I won't drag you through the chain of how we made these discoveries. It led me to medieval Arab scientists, a whole range of which, only one of which I'm going to talk about today, Ibn al-Haytham, known in the Western world as Al-Hazan or Al-Hassan, after his first name. Whoever decided to give him a name in the English world used his first name almost by accident. Ibn al-Haytham, born actually fairly near here in Basra, moved to Cairo, did most of his work in Cairo, in front of the Al-Azhar Mosque, and in roughly 1030, composed his 7-volume Kitab al-Manazir, which and I apologize for my pronunciation, I pronounce every foreign language equally badly. So it's not just that I butcher Arabic, I butcher every foreign language badly. He wrote that, his Kitab al-Manazir, which we translate to English as the Book of Optics, which I am told, and you can contradict me if you disagree with this, really should be translated more as the Book of Vision, not just optics, not just simply lenses. And this is very important because, for reasons I will show you. And then he died in Cairo. In terms of European civilization, the important date is that his book was translated into Latin as Perspectiva or De Aspectibus around 1230, as near as anyone can date. And it was subsequently, 200 years later, translated into Italian, and then subsequently republished. Each time it entered a European language, it sparked new discoveries, new uses by Europeans. And David Lindbergh, a historian of science, calls him the most significant figure in the history of optics in that period. I would say that this really understates his significance, as you will see. Theories of vision, before Ibn al-Haytham and after Ibn al-Haytham. All theories of vision dated to the Greeks. They were 1,000 years earlier. Extramission theories, and there's variations of this, but in general, ooh, horrible colors. Extramission theories said our eyes emit light. I'm seeing George Saliba because my eyeball is emitting light, little particles of light. They illuminate them, and that's what I put together the scene. That's the extramission theories of light. Intramission, now instead, George Saliba is sloughing off atomic thin replicas of himself that mysteriously figure out how to exactly size themselves to enter my eye, and that's what allows me to see them. Combined theories, pneumatic theories, air theories. My eye emits little particles of light that activate the air, and that allows me to see. Well, all of these are wrong. People actually knew they were wrong, but it took Ibn al-Haytham to figure out the correct theory of vision, which involves more than light. It also involves the brain. In Ibn al-Haytham's theory, every point on an object emits a different color. You have to take my word for it on the screen. These are different colors. They all enter the eye, but that's not all that vision is. The brain is involved. The brain takes the information in that allows me to see the IT people standing over here, whoever is sitting, the IT or the cameraman over there, the people in the front row, and put this all together in segments into a unified vision inside my brain. And so this is Ibn al-Haytham's handwriting, and this is the eyeball. If I take away all the visual clutter from this, from the Kitab al-Manazir, so I'll take away the visual clutter, that's the eye. As we know, a way an image is formed in our eye is the lens focuses upside down and with the parity reverse left for right, the image on the back of our eyeball. Kepler is given credit for this. Ibn al-Haytham, that was too much for him to take. He did get this part wrong. Upside down and flipped left for right. He couldn't accept that. So he decided that the region of the eye there is the sensitive region where the eye is still right side up. He was a scientist. He was an experimental scientist. He's responsible for our modern use of the scientific method. The scientific method where I have a hypothesis, I devise an experiment to test the hypothesis, I get the data, I revise my hypothesis in light of the data, come up with a revised hypothesis. That is the scientific method. Ibn al-Haytham was responsible for that. He wrote that down. He did experiments on eyeballs, and he probably knew that he was wrong about this sensitive region because of the experiments he did. Leonardo da Vinci got it wrong for the same reason. So we can't, criticize Ibn al-Haytham too much. So the Book of Optics was completed. It was translated into Latin around 1230. This is a page I got from the British Library, the first page of Perspectiva. Al-Azain's problem is a modern problem. And again, when I go through, if I say Ibn al-Haytham, Al-Azain, Al-Hasan, you just have to remember, it's all the same guy. So I'm going to use this interchangeably because we're going to need this because people did refer to him in different names. Al-Azain's problem is, if you take a spherical mirror, not just a section, but a section of a sphere, but I can only put it in 2 dimensions on the screen, Ibn al-Haytham sees the candle flame on the mirror surface at what looks to be position x1, y1. Well, the question is, what if we move the candle? You'll see it at x2, y2. Where is that? And proof that you cannot determine that point by Euclidean compass and ruler methods was only done in 1998. So it's a modern problem. Problems that Ibn al-Haytham postulated 1,000 years ago are still of interest today. It's also called his billiards problem. The camera obscura. Ibn al-Haytham described what a projected image looked like in this, here's a translation, an analysis in German. This is actually what led me further into, I was trying to figure out, because of what we say today are Islam's prohibition of representations of the human form, could this allow me in some way to figure out whether Ibn al-Haytham was Shiite or Sunni? I mean, I got to say, when I first started doing this, incredibly naive, I did, and maybe I said this to some of you before, I decided some years ago, maybe 4 or 5 years ago, I'm going to learn more about Islam than 99% of educated Americans know. Not just Americans, but educated Americans. unfortunately, I decided after about 3 hours one morning, I'd reached that level. So that was a pretty low bar I set for myself. And I eventually decided, no, I couldn't figure out whether he was Shiite or Sunni. It's much more complicated than that. But he's talked about projected images. Why, I want to know, why didn't he talk about like the human form projected? Fantastic. Chokran. So we have the projected image. Ibn al-Haytham, well, it says here, the works of Vitolo in Al-Hazan had become part of the curriculum. Every student at many universities in Europe were forced to study the work of Vitolo and Al-Hazan. Vitolo was referred to as Al-Hazan's ape. He copied. If you look at Vitolo's work, it's just a straight plagiarism of Ibn al-Haytham. So every time now, whenever you see me refer to Vitolo, you're supposed to think it to yourself also, that's Ibn al-Haytham, just plagiarized by a Catholic priest. Well, let's skip that, because I don't want to run out of time. So, projecting an image. Can we project an image with a concave mirror? This is what led us to our discoveries. And this is a 2-hour lecture I'm going to give you the results of in the next 30 seconds. So there's a lot of information behind here. With a concave mirror, what most people don't know, in my hotel room there is a concave mirror. It's bolted to the wall. If you unbolted it from the wall, you could do this experiment in your hotel room today. His image is reflected and focused upside down onto the wall in front of him. We've been taught that artists worked simply by eyeball alone, simply by tracing somebody. Here, if you can project an image, it allows the artist to trace parts of the image and capture it with much greater realism. And then here's David Hockney tracing the portions of that image, and it's in living color. It's upside down. You can see, if you look carefully, you can see the guy blink. This is creating the optical perspective in the painting or in the drawing. Oops, it's frozen. That's never a good sign. Why is it not moving? Oh. We're going to skip that. The fact that it froze makes me nervous, and I don't want to lock up my computer at this point. So he's captured the painting, he can fill in the color, and he has everything ready to go. The earliest optical texts in Western civilization were Bacon, Vitolo, and Peckham, all completed after Ibn al-Haytham's work was translated into Latin. Significantly, all of these were Roman Catholic priests. They were interested not in understanding optics, they were interested in understanding vision, thinking that if they could understand human vision, that would aid them in understanding theological vision. So their motivation wasn't science, but they were doing science. Leading us to what I'm going to call the theology of light. And you'll see what I mean in a moment. So it's studying physical vision to understand spiritual vision. This is the part where I'm going to teach you now medieval Roman Catholic theology, what you need to know to understand this. Martin Luther is commonly given credit for starting the Protestant Reformation, which broke the Protestant Church from the Roman Catholic Church. However, scholars of religion say really the credit would have gone a little bit earlier, a century earlier, to John Wycliffe, who's called the Morning Star of the Protestant Reformation. Wycliffe translated the Bible from Latin, which only the priesthood could read, to English. So now the people, instead of having to trust what the priest told them was the truth, could decide for themselves. This was a massive heresy. I was stunned at this point when I found this. When I was younger, written by Wycliffe, I collected from the manuals of optics the properties of lights and the truths of mathematics. He studied optics in order to understand theology. Let's look into this deeper. Wycliffe, in a different text, classified spiritual vision into two kinds, sensory and intellective, and he said, if you want to know more about this, consult Ibn al-Haytham. So here we have someone who's responsible for the Protestant Reformation who's telling you, if you want to understand the theology I'm going to do, that's we're going to transform the Catholic Church, read what this Arab scientist wrote. And he called vision, there's distinct vision, which I'll simplify as saying it's like what we sort of think about, but there's intellective vision. We recognize that as a human being, although it's not a human being at all. And Ibn al-Haytham tells us why we do that. Our brain power processing tells us that that's a human being. There's also different types of vision. There's direct spiritual vision. That's closest to God. It's unimpeded by anything. There's refracted vision. When you wear spectacles, you're not quite seeing things exactly as God intended them to be, so they're a little bit distorted. And then there's reflected vision, like reflected from a bad medieval mirror, things are distorted. That's what humans are. That's what we're supposed to overcome. It gets even better. These are the 7 deadly sins by Hieronymus Bosch, 1480, and these are the 7 deadly sins in Christian teaching. Wrath, pride, lust, these are bad things. Wycliffe, in a different book, which we've translated, equated each of the failings of a human being with the distortions of the 7 types of mirrors in the analysis given by Ibn al-Haytham. So this is getting awfully suspicious that he's building an entire theology on this Muslim scientist. Took a year to get this. This is the Eucharista. We got this from the National Library of the Czech Republic, which really interested me. So I got this looking through this Eucharista where he describes these theories of vision. He uses the Arabic word for a concave mirror, mukefi. So this is really a smoking gun of what he's done, that he's taking this from Ibn al-Haytham. The most sacred sacrament of the Roman Catholic Church is at a given time, the priest puts a wafer on your tongue. At that moment, that wafer becomes the body of Jesus Christ. Now, this causes lots of people, lots of Christians, problems. How can that be? I mean, there's lots of, we don't even need to go into all the problems that causes. But one problem that priests were concerned with is how can 2 good Roman Catholics in 2 locations, different parts of the world, simultaneously have Christ transubstantiated on them. And John Wycliffe said, we can solve this with optics. That his interpretation of the Bible was, the Bible doesn't require this to actually be the body of Christ. That he decided at every point in the brain, there is a figure, a mukefi, which concentrates light. And he says there's a problem with this, that Christ in this position is upside down with his organs reversed. This is the first description of a projected image. We're going to be publishing this in about 2 months in a widely read scientific review article. It's the very first description of a projected image in Western literature, and it owes itself directly to Ibn al-Haytham. So there'll be a lot of interest in this. And so what he's saying is, the wafer isn't actually the body of Christ. The wafer is a whole bunch of parabolic mirrors that project the intense image of Christ upside down and flipped left for right. So a postscript, it's never a bad thing to get yourself too involved in heresy. He made a good career move. He had a stroke and died before the church could execute him. The Pope in 1409 ordered him, all his books surrendered. He was tried 20 years after he died for heresy and convicted of heresy, and the Pope ordered his body to be exhumed and burned at the stake for the heresy of having this optics-based theology. It didn't happen. A different Pope, another 20 years later, realized it hadn't happened. He ordered it to be done, and at that point he was exhumed and burned at the stake.
That is blasphemy.
So it is blasphemy. So he was burned at the stake for this. So the moral of the story is, if you invoke an optical explanation for something sacred, you'll burn in hell. Which is difficult for me because I'm an optical scientist. Jan Hus took his theology over. He was ordained as a priest. He used Wycliffe's teaching. He was burned at the stake using Wycliffe's textbooks as kindling, as documented, which started a revolution, and Joan of Arc was very upset with this, and Joan of Arc sent a message that to them, if I weren't busy with the English in the 100 Years' Wars, like the Saracens, like the Muslims, you have ruined the true faith. So Muslims appear in various places as bad people here. So we'll end that. Literature. So I've told you how Ibn al-Haytham has influenced in a way that is never been discussed before, never been discovered before, the religion of Western Europe. He appears in the literature. Chaucer's Canterbury's Tales was one of the greatest and almost first works in the vernacular English language, and these are places that refer to mirrors and such. If I magnify one of them, they referred to many a learned tome by Aristotle and Al-Hazain, Ibn al-Haytham, and Vitalo, the person who plagiarized Ibn al-Haytham, appears in the works. So Ibn al-Haytham was widely known at the time, not today. In the Romance of the Rose, also contemporary, Hussein, which I assume refers to Jonanitis, but here I'm not going to take the trouble to clarify the shapes of mirrors or tell you how they're reflected. It's all described in a book, and the book is described is Ibn al-Haytham's treatise. Certain mirrors even make phantoms appear quite alive outside the mirror, and this is David Hockney. Doesn't really matter.
I realized this is a color movie. It moves. I mean,